Okay, the third problem is an ideal gas law. And this one is, the first thing is read the problem is the most important. I'll highlight this. So what kind of information is given? They given to me that gas has a mass. Okay, so I know the mass of a gas. This is a gas. And their mass is known. So mass is known. And then this one is decomposed into only two, which is an oxygen and the sulfur. Okay, and the oxygen is 2.1 grams, and then this is a 1.5 grams of sulfur. So they know the mass. So what's implying here is this gas is essentially made out of sulfur and oxygen. Okay, that's what it means that they break it into, and what they want is they give you that, okay, before the decomposition of this gas, this has a volume of such and such, at the pressure of such and such, at the temperature of such and such. And they ask you what is the molecular formula of this gas. So what it means is they can figure out what is a number of N, what is the number of M here. This is what they wanted to find. Is it SO2, SO3, S2O4, whatever the number that you can find the closest one, how these molecules are being made up. And the simple idea is, okay, I think that I know the mass ratio. So this is the mass ratio. I can calculate the mole ratio. Okay, you know each one, whether this is a tricky, okay? So yeah, they have to say oxygen is an O2, but what that means is essentially what they mean by this is an oxygen. So I can use the oxygen. I just want to count the oxygen atom number, how many atoms are there. So whether it's an O2 or whatever, that this is an oxygen, I can count the number of oxygen atoms. Right? If you want to say oxygen molecule, I guess half of the oxygen atom number is what you have. But anyway, so if you got the mole ratio, and the mole ratio, and find the closest one, and that's why we call the molecular formula. The one that probably you have familiar with, H2O means 2 hydrogen, 1 oxygen, that's the ratio, that's what it is. So now let's do this, and therefore you have 1.5 grams divided by, I mean, you don't need this. I don't know why do they do that, but it's a 1.5 divided by 3.6 grams. So that's a total gram. So that's the weight ratio for oxygen and the sulfur. So this is looks like this is a 40 gram, 60 gram, or 1.448 gram and 2.17 gram. You can do either way. This step is not necessary, but I think they just wanted to give you some number that is big enough for you to get familiar. Okay. What is more important one is a step that involve this. Let's say that's a 40 gram, 60 gram ratio, mass ratio. So let's just assume that this one is 40 gram and 60 gram, and you divide by the atomic mass. That's a sulfur atomic mass. That's the oxygen atomic mass, and you start to see that 1.2, 3.7 mole ratio, which is not integer. Okay? So whatever the number you have, what you're going to do is you are going to pick the one that is smallest, which is this one, and then I'm going to divide this one by 1.247. Divide by 1.247. And then this one is 1. This one guaranteed to be 3. Approximately to be 3. So you're going to pick the one that is small. And you got this 1 to 3 ratio. What that means is the ratio between mole ratio is 1 to 3 ratio. So either SO3 or S2O6, etc. Right? So those are the candidates that maintain the same mole ratio. And then this second information, they said, okay, volume, temperature, and pressure. I can calculate number of moles, and the mass. Number of moles, mass, I guess I can calculate the molecular weight. And this is what they did, because I know the ratio-wise, there are many choices. Mass and the number of moles is, you can use that. So number of moles is putting the pressure, changing to the ATM pressure, milliliter to the liter, because that's a 1.12 liter, so 1.12 liter. And using this number, that allow you to use the ATM, the liters, so 0.082. And then that's the conversion into the temperature. And then you got this one. Okay. So what this number is, this is the number of mole that can give you this weight. So all you gotta do is this one divide by number of moles. By doing so, per mole, how much it weighs, that's an 80 grams per mole. 80 grams per mole, whether this one or that one, this is the right answer. So that's how you do it. Okay. So if I'm just making a guess, if you guys do this, and if you guys have a 1.0, then that's a choice. The smallest number of moles, and then you divide this number by itself, the smallest one. So this is a 1. And if you find that this one happened to be 1.5, right? If it is, and then your choice will be, it is 2 to 3 ratio, right? This is a little bit more difficult kind of situation, right? This one happened to be 1 to 3 ratio, that's fine. But if you divide by 1 and this is a 1.5, 1.496 or something, and then, okay, that must be the 2 to 3 ratio, and that must be, then your logic is, I mean, this is 4, saying 4, 6, etc. So these are your choices, and then you figure out your molecular weight and choose which is the answer. Right? This is not the right scenario here. Right? I'm just saying that the 1.5 is number showing up, and you gotta make sure that you multiply another numbers to make the closest integer ratio, because that's the molecules that combine.